One of the things that's most difficult about drawing electric fields or gravitational fields is when you have more than one object, more than one mass, more than one charge, because each of these objects, whether they be masses or charges, they exert some influence on the field that's being generated. So I'm going to show you a few examples. I think it's the best way to try and understand how to draw these. And I'll explain my method, which I think kind of has some things in. When it comes to electric fields, one of the most difficult things to visualize is the electric field around multiple masses or multiple charges. So more than one charge, more than one mass. I'm going to walk you through a few examples just so you understand the process that I apply, which I think simplifies these multi-object fields a little bit. So the first thing we want to do is kind of going along with the rules of drawing electric fields. We have to understand that the sizes of the masses in this case should be representative of the number of arrows that are emanating from them. And what I mean by that is I'm going to look at these three, and I'm going to see that 200 is the lowest mass. Now the fewest number of field lines you ever want to use is 4. If you don't have 4, so you can do like top, bottom, left, right. If you don't have 4, you use 3 or 2. It gets a little bit tricky when you're trying to kind of represent the field. You basically don't have enough lines to accurately represent the field. So in this case, I'm going to use 4 for my 200 kilogram mass. So before I draw the lines, I draw these little dashes. So top, bottom, left, right for the 200 kilogram mass, because that's my smallest. If I look at the 400 gram mass, well, that is twice the mass of the 200, so I give it twice as many lines. So if the 200 kilogram mass has 4 lines, the 400 is going to have 8. Likewise, if the 200 has 4 and 800 is 4 times the mass, it needs 4 times the number of lines, so 16 lines. I could also compare it to the 400. If the 400 kilogram has 8 lines and 800 is double that, then the 800 needs to have 16. So you get a sense of how I'm kind of spacing these out, and I'm making sure that relative to one another, they have the same number. Now what I want to start to realize is with any one of these, if I place a mass anywhere near these, they're going to get pulled towards that. So I'm going to show you what the field lines look on this, and you might be surprised to see that in this case, they actually have curved. There's some curvature to them. And the way to think about that is if I placed a mass, let's say here, you're going to have the 400 kilogram mass pulling on it. You're going to have the 200 pulling on it, but you're going to have the 800 that's pulling on it to a much higher degree because it's a larger mass. It's much closer. You can think about Newton's universal law of gravitation. So the reason you get these curves, is because that object is going to want to get pulled by the 400 and the 200, but the 800 is going to win out. So it's going to kind of start maybe like this because it's influenced by both, but then as it gets closer to the 800 kind of starts to win that battle for that mass in terms of force. So the reason those lines curve, you can think of it as the other two masses are exerting an influence, but they're too far away, so they don't exert enough influence to actually pull those objects. But you can kind of think like the influence that they do have is causing some of that curvature. It's like they're trying to pull those lines towards them so they get a little bit of this curvature.